Welcome to the deep dive. We're here to cut through the noise, distill complex information, and really help you become truly well-informed. Today, we're diving deep into the huge and often surprising world of Linux. We're using a real cornerstone text for this, Running Linux, 5th edition. Our mission here really is to give you a shortcut, a way to understand not just what Linux is, but maybe more importantly, why it's become such a foundational piece of technology. We'll cover everything from its core philosophy, that open collaboration idea, to its incredible versatility. I mean, it's everywhere, from your phone to supercomputers. So get ready. We're going to uncover some surprising facts, maybe a few aha moments about an operating system that, well, it really helps run our modern world. Okay, so let's unpack this a bit. When this book was first being thought about, Linux was, barely even a blip on the radar. It started small, maybe around 30,000 users back in 1995. But here's the mind-blowing part. Just 10 years later, that number exploded. Hundreds of millions. It went from this niche thing to a global phenomenon.
The book says it's used everywhere on the planet, and in some cases in outer space and under the ocean. Literally. So, yeah, you might be using Linux right now without even knowing it for everyday stuff, browsing, email, streaming videos, maybe Office apps. But here's where it gets really interesting, I think. That same core Linux system, it's also powering sonar arrays on nuclear submarines. It's indexing pretty much the entire internet. It's running huge corporate data centers, powering nearly 70% of all websites, recording your TV shows, running the switches for global telecom networks. It's even on the International Space Station and the shuttles. It's the ultimate chameleon, really.
It is. And what's truly fascinating here isn't just where it's used, but the philosophy behind it. That's what allowed this incredible growth. A lot of people see Linux as maybe the largest cooperative software development project in human history. And that's not just hype. It's not just about sharing the code, though that's huge. It really embodies this do-it-yourself attitude. It's baked into the culture. Developers get full access to the source code. They can look at it, they can change it, they can improve every single part of it. And this open approach, it's not just for hobbyists messing around. Businesses realize pretty quickly that Linux offers this incredibly inexpensive, efficient, and crucially robust system, especially for things that absolutely cannot fail, mission-critical applications. Take Sendent Travel Distribution Services. That's a great example in the book. They moved their big fares application onto a Linux enterprise server. And the results, well, they cut their costs by 90%. 90%, while getting 99.999% uptime, that's 5 nines, and handling hundreds of transactions every second. That kind of performance, plus the ease of customization, even down to the guts of the kernel, that makes it incredibly attractive if you need precise control and serious reliability.
Wow, 90% reduction and 5 nines uptime. That's a really powerful endorsement for its design. So, okay, for listeners who maybe know operating systems but haven't really dived deep into Linux itself, what does this mean for actually using it? How do you interact with something this versatile? Well, for a lot of people, the main gateway, the real entry point to Linux's power is the shell. And it's not just, a place you type commands. It kind of embodies that whole do-it-yourself philosophy we talked about. The shell gives you this, surgical precision over the system. You can manage jobs, redirect input and output in complex ways, even write scripts to automate tasks. There are different shells, but the most popular one most people run into, is the GNU Born-Again shell, or just Bash. And Bash has some really neat features that make life easier. Things like command history, so you can reuse commands and smart completion. You type a few letters, hit the tab key, and bam, it often finishes the command or file name for you, or shows you the options. It really speeds things up.
Definitely. But while the command line is, immensely powerful and precise, Linux isn't just for people who love typing commands all day. It also has these really sophisticated graphical desktop environments. Think KDE and GNOME. They offer a very customizable, integrated experience. But importantly, they still kind of reflect that Linux ethos of user control. You're not just stuck with one way of doing things. KDE, for example, it's got this great session management. So you log out, log back in, and your applications can pop right back up where you left them. It comes with its own window manager, a file manager, and this web browser called Conqueror. Conqueror itself has handy features like tabbed browsing, history, bookmarks, the usual stuff. But what's really insightful about KDE, I think, is its design philosophy. It's not just an item collection of apps. It's designed as an integrated suite. It aims for a coherent feel, very customizable, but it can still run pretty much any other standard Linux graphical application you might need. And then you've got Geno. It has its own file manager called Nautilus, which uses this metaphor where each window is like a folder. It's quite intuitive for some people. And its evolution calendar is really powerful. Flexible scheduling, multiple color-coded calendars, event management, even integrated email. So these environments, KDE and GNOME, they really show the depth of choice you have on Linux. You can really tailor your desktop to fit exactly how you like to work.
That makes sense. Choice seems to be a big theme here. We've talked about the power, the flexibility, some great tools. But what's actually making all that happen behind the scenes? Let's peel back another layer and look at the core components. What makes Linux tick?
Okay, yeah. Understanding file systems is absolutely fundamental here. It's basically how your data gets organized and stored on your disk. A bit like formatting a partition in Windows, but, well, more options. The most common types you'll run into are probably the second and third extended file systems. That's x23s and XT3s. They handle long file names, really big file sizes, up to 32 terabytes, which is huge. Now, a really key difference, especially with X3s and some others like ReiserFS or JFS, is journaling. Think of it like a logbook that the file system keeps. If your system crashes unexpectedly, this journal lets it recover much, much faster and helps prevent data corruption. It really boosts reliability. And you interact with these using commands, like mount makes a file system available, mount disconnects it. There's also a configuration file, etc. stab that handles mounting things automatically when you boot up, saves you doing it manually every time. Oh, and speaking of boot time, you also set up swap space. That's like virtual memory, letting your system use disk space if it runs out of physical RAM. Use commands like mkswap to prepare it and swap on to enable it.
Right, so file systems handle the data storage. What about managing the actual running programs? You mentioned that earlier. Yeah, the concept of a process is absolutely central to how Linux and Unix systems in general work. Think of it like this. Every single running program, every command you type, every background service, it's all a process. And the kernel, the core of the OS, is meticulously managing all of them. There's one special process called init. It's usually the first one started. And it's responsible for kicking off all the other initial processes and running startup scripts when the system boots. All that is controlled by another config file. It's a finite tab. And if you want to see what processes are currently running, you just use the X command. Gives you a snapshot.
And how does this system talk to the hardware? Keyboards, mice, drives? Good question. That's where device files come in. You find these in a special directory dev. Now, these aren't files like text files or images. They're more like special pointers or interfaces. They're clever abstractions. They let programs talk to hardware devices like your hard drive or your mouse through the kernel using unique ID numbers called major and minor device numbers. So, for instance, DevDA might be your first IDE hard drive. Often you'll see symbolic links used too, like devmouse might point to the actual specific device file for your mouse. It just makes it easier to refer to common devices without needing to know the nitty-gritty hardware details. It simplifies things quite a bit.
That is clever. Hiding the complexity, but keeping the control. Okay, one last thing on system basics. Shutting down. You mentioned it's important. Absolutely vital. You really should just hit the power button or pull the plug on a Linux system. You need to use the shutdown command. It has options like degr tells it to reboot, degr tells it to halt or power off. Using shutdown ensures everything gets written to disk properly, file systems are mounted cleanly, it's a graceful exit, prevents data loss, and potential file system corruption. Always shut down properly. Got it. Okay, so we've covered the philosophy, the user interfaces, the system guts. What about building things, creating software? You said Linux is a developer's paradise. It really is. And the C programming language, well, it's often called the native tongue of Unix, and that includes Linux. The main tool for this is the GNU compiler collection, usually just called GCC. It's this incredibly versatile, incredibly advanced compiler. And it's open source, which is huge.
Yeah, GCC is amazing. It's not just for C either. It handles C++ natively, and it can even compile Java code, among other languages. It's designed really smartly, too. It acts as a kind of front end, coordinating other tools needed for compilation, so you can easily compile programs made up of multiple source files. And when you're working with code from elsewhere, external libraries, you use options like -I to tell it where to find include files, and -L for library files. Getting those right, especially at order you link libraries in, can sometimes be tricky, as any developer knows, but GCC gives you that fine-grained control. This kind of powerful open tooling is why so many developers love Linux.
Right. Compiling individual files is one thing, but what about bigger projects? Managing all the dependencies. That sounds complicated. That's where makefiles come in. They are absolutely essential for automating the build process, especially for larger software projects. You write instructions in a makefile, and then you run the make command. Make reads the file, and it's smart enough to figure out which parts of your project need to be recompiled based on what files have changed. It only rebuilds what's necessary, which can save you a ton of time compared to recompiling everything every time. Makefiles can even have these things called phony targets. These are like commands you can run, maybe make install or make clean, that don't actually create a file, but just run specific shell commands. Super flexible.
Okay, so make helps build it, but what happens when your beautiful code doesn't work? When you have bugs? Yeah, inevitably. That's when you reach for GDB, the GNU debugger. It's your best friend when things go wrong. First, you need to compile your code with a special debugging flag, usually -G. This tells the compiler to include extra information that GDB can use. Then, you run your program under GDB. You can set breakpoints. These are specific lines in your code where you want GDB to pause execution. Once it's paused, you can examine variables, step through the code line by line, figure out the program state. It lets you trace exactly what's happening and pinpoint where the logic goes wrong. It's indispensable for serious debugging.
Debugging tools are crucial. And what about understanding how things work in the first place? Documentation. Absolutely. And Linux has a strong culture of documentation. The most famous are probably the manual pages, or man pages. You just type man followed by a command name like man-ls, and you get detailed information about it. There are also info pages, which are often more comprehensive, kind of like hypertext documents you can navigate. You can read them with tools like Emacs or a dedicated info command. And for creating really comprehensive documentation, there's a system called TextInfo. The commitment to having clear, accessible docs is, well, it's very much part of that open source spirit. You mentioned Emacs there. Along with V, these are kind of the legendary text editors in the Unix and Linux world, right? They really are. And they're not just simple notepads like you might find elsewhere. They are incredibly powerful, highly customizable programming environments in their own right. V, and its modern version, Vim, has this distinct modal interface command mode, insert mode, which can be incredibly efficient once you learn it. Emacs, on the other hand, is famous for its, well, almost infinite customizability using Lisp. It has powerful macro capabilities. People have built entire workflows inside Emacs, email clients, newsreaders, even interfaces for compiling code directly within the editor. Both V and Emacs really emphasize powerful keyboard-driven editing and productivity, which fits perfectly with that command line philosophy.
That's a great look at the developer side. Really powerful stuff. But let's switch gears a bit. For listeners who aren't developers, what about just using Linux? For everyday tasks, productivity, multimedia, maybe even some fun, what can you do with Linux besides coding and command lines? And the answer, as you might guess by now, is a huge amount. Okay, let's talk productivity first. OpenOffice, or its modern successor LibreOffice, is a really capable, full-featured Office suite. It's a strong open-source alternative to commercial software. Its word processor, @Writer, handles various file formats, including the standard open document format, .odt. It has advanced features too, like auto page numbering, table of contents generation, all the stuff you'd expect. Then there's Calc, the spreadsheet, handles multiple sheets, lets you freeze panes so headers stay visible, and can even connect to external databases like MySQL to pull in data. Pretty powerful. And Impress is for presentations. A neat feature is it can export directly to HTML or even Macromedia Flash, making it super easy to share presentations on the web. It really shows how open source can stand toe-to-toe with proprietary options. And there's also Office, which is tightly integrated with the KDE desktop environment we mentioned earlier. Office is often noted for being quite lightweight. It starts up fast, doesn't use a ton of memory, which can make it a great choice, especially if you're running Linux on maybe slightly older hardware.
Okay, Office Suite's covered. What about multimedia, pictures, music, video? That's a big part of what people do with computers. Oh yeah, Linux definitely shines here too. It shows off its versatility again. You can easily play all the popular audio formats, MP3, OGG Vorbis, FLAC, you name it. For image editing, the big one is the GIMP. That stands for GNU Image Manipulation Program. It's an incredibly powerful, free alternative to things like Adobe Photoshop. It has all the advanced features professionals need. Layers, channels, sophisticated color tools, filters, scripting. It's seriously capable. And if you're into creating music, Linux has tools for that too. There are MIDI sequencers like Brahms, and even full-blown composition environments like Rose Garden that let you score, record, and mix music. What about physical media, burning CDs or DVDs? Simple. There are great tools like K3B. It's very user-friendly, usually detects your CD, DVD drives automatically. You can easily create data disks, audio CDs, copy disks. It even has options to verify the data after writing to make sure it burned correctly. Very straightforward. Linux also has tons of multimedia players to choose from, and its sound system architecture, often based on things like Pulse Audio or Pipewire these days, the book mentions ARTS, is designed to let multiple applications play sounds at the same time without them interfering with each other. You can even do internet telephony and video conferencing. Tools like Kphone or No Meeting, or more modern equivalents like Jitsi or various web clients, let you connect with people anywhere.
Sounds pretty comprehensive. What about games? Is Linux just for serious work? Ha! Definitely not. The Linux gaming scene, especially considering its roots, is surprisingly vibrant. Maybe not always day one releases like Windows, but there's a lot there. A lot of classic first-person shooters got native Linux versions. Think Quake the Third Arena, Return to Castle Wolfenstein, Unreal Tournament 2004. These often had a strong focus on multiplayer. And if you're feeling nostalgic, Linux is fantastic for emulation. Xmami lets you play thousands of old arcade games. SNES 9X handles Super Nintendo games. There are emulators for practically every classic console. And there's casual stuff, too. Fun puzzle games like Frozen Bubble were really popular. And who can forget Tux Racer, the 3D racing game where you slide down hills as Tux, the Linux Penguin mascot. It shows the community builds things for fun, too.
Tux Racer. I remember that one. Okay, so work, multimedia, gaming. What about something really practical like personal finance? Yep, Linux has answers there too. Ucash is a really powerful personal and small business finance application. It uses proper double entry accounting, which is the standard for serious bookkeeping. You set up different accounts, assets like your bank account, liabilities like loans, income, expenses. Then you track transactions between them. Ucash makes it really clear how money flows. As the book puts it, money always comes from some account and goes to another. This helps you understand even complex things, like how getting a tax refund isn't just income, it's also increasing your assets. It offers real clarity for managing your finances. Another example of a robust open source solution for common need. Okay, so Linux clearly do a lot on a single machine, but its origins are deeply tied to networking, right? Connecting computers together, absolutely. Linux is, at its core, a network powerhouse. It was built with networking in mind from the very beginning. It includes a full, robust implementation of TCP/IP, which is the fundamental protocol suite that runs the entire internet and most local networks today. So connecting to your LAN or the wider internet is seamless.
And how do you manage those connections? Setting up IP addresses and things like that. You typically use foundational command line tools like ifconfig or the newer ipcommand and route. These let you configure IP addresses, net masks, default gateways, basically setting up your machine's identity and path on the network. There are also important concepts like masquerading, which is more commonly known today as network address translation, or NAT. This is what lets multiple computers on your home network share a single public IP address provided by your ISP. It's essential for most home setups. And for security, especially when connecting to other machines remotely, SSH, the secure shell, is absolutely critical. Linux uses OpenSSH, which is the standard implementation. It encrypts all your communication logins, file transfers, everything protecting it from anyone trying to eavesdrop on the network. Security is paramount.
Makes sense. Security is key. Now, what about sharing resources between machines on a network, like files or printers, especially in mixed environments with, say, Windows machines? Linux is incredibly versatile here too. For integrating with Windows networks, the go-to solution is Samba. Samba speaks the same networking protocols that Windows uses, SMBCIFS. This means your Linux machine can act as a file server or print server that Windows clients can access just like any other Windows server, or vice versa. You configure it mainly through a file called smb.conf, where you define things like the workgroup name, which directories you want to share, access permissions, and so on. It enables seamless cross-platform sharing.
Okay, Samba for Windows interoperability. What about sharing between Linux or other Unix-like systems? For that, the traditional and highly efficient protocol is NFS, the Network File System. It's designed specifically for sharing file systems between Unix-like machines transparently. And if you have a larger network with multiple Linux Unix machines, managing user accounts on each one can be a pain. That's where NIS, the Network Information System, comes in. NIS, or its more modern successors, lets you centralize user and group information on one server, and then other machines on the network can access that common database. It drastically simplifies user administration across many systems. It's all about making network management smoother.
And printers. Printing can sometimes be tricky, especially network printing. Historically, yes, it could be, but things have improved a lot. The modern standard printing system on Linux is CUPS, the common Unix printing system. It replaced some older, more complex systems. CUPS has a central process, CUPS-bed, that manages print queues and jobs. It can talk back to applications about printer features like paper sizes or duplexing capabilities. CUPS also supports automatic network printer discovery, often called browsing. This means it can often find shared printers on your network automatically, which really simplifies setup. And you still have command line tools to manage print jobs. LPStat to check the status, LPRM to cancel a job, LPOOP to move a job to a different printer queue. It provides a robust, unified way to handle printing.
That sounds much better than the old days. Okay, so we've covered a massive amount of ground philosophy, usage, admin, development, apps, networking. With such a rich, sometimes complex ecosystem, how do people learn? How do they find help or figure things out within Linux? That goes back to the documentation culture we touched on. It's really a cornerstone. Beyond those standard man pages and info documents, a huge amount of documentation nowadays is just in HTML format. You can read it in any web browser. Plus, many commands have built-in help. Just typing the command followed by dash or help often gives you a quick summary of how to use it right there in the terminal. Very handy for a quick reminder. And the online community is massive. Websites like FreshMeat, back in the day, or newer sites like kd-apps.org, GitHub, GitLab, they are huge repositories of Linux software, often with forums or issue trackers. And if you truly can't find an application that does exactly what you need, well, that do-it-yourself spirit often kicks in. People might try to port an application from another operating system or even decide to write it themselves. And because it's open source, they can often find other people in the community willing to collaborate. It fosters this amazing culture of shared creation and problem solving.
That's a great point. It really comes full circle back to that cooperative philosophy. So wrapping this all up, what's the big takeaway here? This deep dive into running Linux, it feels like it's about more than just technical details, right? It really illuminates this profound philosophy. It's about customization at a level you rarely see elsewhere. It's about community-driven development. It's about transparency, being able to see how things work. It's just fascinating, I think, to see how all these different pieces, from a tiny shell command to a complex network protocol to a kernel module, how they all work together to create this incredibly adaptable system. Remember that example from the book about restoring old vacuum tube radios? That was fantastic. Using Audacity on Linux to digitize old records or tapes, clean up the audio, convert it to MP3, organize playlists with a music player like Juke. And then this is the kicker, using a low-power AM transmitter hooked up to the sound card to actually broadcast those restored recordings throughout your house. That just perfectly exemplifies how you can combine these Linux tools in really surprising, creative ways to solve unique, real-world problems.
It's not like digital craftsmanship.
Exactly. And if we connect that to the bigger picture, Linux is never static. It's constantly evolving. You have these kernel hackers always pushing the boundaries, experimenting. Using Linux, especially if you dig deeper, really encourages critical thinking. It pushes you to understand the why behind things, not just the what. And there's this interesting balance. You have incredible convenience through things like automated package managers that install software easily. But you also have the option for deep, granular control, like manually configuring the kernel if you really need to. That balance is a core strength. It really emphasizes that learning is ongoing, there's always more to discover. And having multiple ways to do things, multiple perspectives, choosing a shell, setting up a file system, deploying a huge application, that diversity actually enriches the whole ecosystem. It invites you to be an active participant and not just a passive consumer of technology.
That's a perfect summary. We hope this deep dive has given all of you a fresh, maybe deeper perspective on the incredible Linux universe. We've really only scratched the surface here, obviously. But think about that core idea, the do-it-yourself ethos. From the kernel itself to everyday applications, it encourages this unique kind of digital craftsmanship, this problem-solving mindset. So here's the thought to leave you with. How might that philosophy, that idea of not just using tools, but understanding, modifying, and shaping them, how might that influence your own approach to technology, even beyond Linux? Something to think about. We encourage you to explore it. Join us next time for another deep dive.